What I have here are known as stromatolites. They are fossils of very, very primitive life, very primitive life known as microbial life, prokaryotic microbial life, which includes such things used to be known as blue-green algae. Now it's known as cyanobacteria. But they're some of the very earliest forms of life that lived on the planet before 2 billion years ago. Stromatolites are some of the most abundant fossils in the very early record of life on the Earth. And they come in quite a variety of forms. There's a couple of videos on YouTube, as well as a couple that I've made, that go through the diversity of different types of stromatolites, the diversity of different forms of them, and presumably formed by different communities of microbial life living in shallow water for the most part, photosynthesizing. But an interesting aspect about this is that sometimes associated with these stromatolites are found what are essentially hydrocarbons, essentially very hard hydrocarbons, similar in some ways to, gilsonite, and similar in some ways to very hard asphalt. Hydrocarbons are essentially petroleum, and it's fairly certain that these hydrocarbons have been produced from the algae or the cyanobacteria that form the stromatolites, and represent some of the earliest organic material that exists in the rock record. Some of it extends back as far as almost 3 billion years. Stromatolites, in fact, occur back as far back as 3.5 billion years in the history of the Earth, and for literally well over 1 billion years were the major form of life that lived on the planet. Very ancient Precambrian hydrocarbons are collectively known as Anthroxolite. It's a very hard, very brittle hydrocarbon, and it is the oldest petroleum essentially that is found in the Earth's crust. And it's of interest because it is derived from some of the earliest life that occurred in the Earth over 2 billion years ago. And here's a few examples of them. These specimens right here, this stromatolite from the Gunflint Formation in Western Ontario. And if you look on the screen, this black material that you see right here is Anthroxolite. This is this very, very ancient Precambrian hydrocarbon that's probably produced from the algae or the cyanobacteria that you find fossilized associated with it. And here's another one from the Gunflint Formation. The black areas that you see on the screen are the areas of Anthroxolite, and it often occurs in a rather typical and characteristic signature that you see here. Actually is very typical of it. Here's another one. This is from rocks about 1.4, possibly older, 1.5 billion years, are possibly older, from southern Missouri. And again, you see that black scattering of hydrocarbon material, the mineral Anthroxolite, scattered throughout what is essentially known as a tufaceous iron formation. These stromatolites and the Anthroxolite that form from them are often found associated with what is known as iron formation, which is a peculiar rock that's characteristic of the early history of the Earth. And it appears, and today is pretty well agreed, that it's a biogenic sediment that was produced in the process of the oxidation of the Earth's atmosphere, the accumulation of oxygen that built up starting about 2.5 billion years and gradually increased to the 21% that we have today. Now, the next thing we're going to look at is going back about almost 2 more billion years. This is a slice of what is known as a carbonaceous chondritic meteorite. It fell in 1969 near the Mexican town of Allende. And carbonaceous chondrites contain a material similar to anthroxolite. It's essentially a hydrocarbon. And being from outer space, not being from the Earth, the hydrocarbons that are found in carbonaceous chondrites are derived in some manner other than from life. For a while, there was excitement, particularly in the 1950s, that possibly carbonaceous chondrites reflected the presence of life in some other part of the solar system, or possibly beyond. But that's been pretty well written off, that what the anthroxolite-like material found in carbonaceous chondrites is actually a synthetically produced or non-biogenic produced form of hydrocarbon that produced by a process similar to what is known as the Miller experiment, which was an experiment that was done in the 1950s, setting up a series of energy sources and subjecting a mixture of methane and ammonia and water. Essentially, over a period of time, the water would appear to be yellowish and then reddish, and finally a blackish gunk would appear, which was a hydrocarbon, or a hydrocarbon consisting of a number of other materials as well. Very similar in composition to the organic material found in these carbonaceous chondritic meteorites, the specimen like you saw on the screen from Mexico, the Allende. And the next episode in this saga of very, very ancient hydrocarbons is the mysterious reddish and yellowish, brownish material that is seen with a telescope originally on one of the satellites of Saturn, the satellite known as Titan. Titan has a reddish color to it if you look at it with a big telescope. And it was always puzzling what that reddish material is. With space probes that were sent in the 1980s, I believe, flyby to the satellite of Saturn, Titan, showed that the material is similar to the material found in carbonaceous chondrites. And in the 1990s, Carl Sagan essentially coined a term to represent this material, and what he coined is the word tholins. And they're compounds of complex organic material, but containing quite a bit of hydrocarbons, very similar to the carbon material in carbonaceous chondritic meteorites, which in turn is similar in ways to the Anthroxolite found in some of the very earliest evidence of life on the Earth, the stromatolites like those found in 2 billion-year-old rocks in Western Ontario and elsewhere. Organic complex tholin, or what are known as tholins, occurs not only on, and Jupiter, though, is also in its atmosphere apparently composed to a major extent of tholins. When the comet Shoemaker-Levy collided with Jupiter, it kicked up a bunch of yellowish, reddish material similar to the red spot on Jupiter, this pronounced spot, which is believed to be a huge storm that's been in progress for over 250 years. This red spot on Jupiter is essentially the tholins being brought to the surface where you can see them with a telescope, and they've been known for about 250 years. And it's apparently another occurrence of this complex hydrocarbon mass or mix of other material known as tholins. And it looks like tholins are a fairly common component of the outer solar system, and as well as Jupiter, which is I would say the middle part of the solar system, but it has more characteristics of the outer. It's a giant gas ball planet, for one thing, like Saturn, and Saturn also has these reddish, yellowish compounds on it, which are almost certainly tholins as well. And they really appear to be a common material in the outer solar system. And as I've mentioned before and shown, carbonaceous chondritic meteorites have similar material composing them as their organic component. The inorganically produced organic material. This is kind of confusing in a way, because you have organic material, which is what life's composed of, and then you have this material that occurs in the outer solar system and in carbonaceous meteorites and composes tholins, and this is chemically an organic compound, and are massive compounds, but it is not produced by life. So in a way, it's inorganic material. It is confusing. It is confusing to a lot of people. The production of material like this was done in the 1950s, as I mentioned earlier, the so-called Miller experiment that experimentally produced materials like tholins under a laboratory condition using various energy sources. It used, first of all, used X-rays. It used the first of which was electrical sparks, a fairly high voltage in a aqueous environment, essentially hydrogen gas, carbon dioxide, and of course water vapor. It was essentially the water that would turn first yellowish, and then it turns kind of brownish, and finally reddish brown, which were tholins being produced. It looks as though any source of energy, potentially under cold conditions such as exist in the outer solar system, are capable of producing tholins. Now, getting back to the Anthroxolite that occurs in rocks in the earth, this is a hydrocarbon and a sort of petroleum-like material that is produced by living things. It's produced biogenically, but it shows a similarity between the early Earth, where these compounds were produced by very primitive life forms, and it's possible that some of the Anthroxolite that's found in very, very ancient rocks of what is known as the Archean era. It wouldn't surprise me, and this is something people who are working in these very, very ancient rocks, and including myself, I find them extremely interesting. But these very, very ancient rocks very likely will produce anthroxolites, and probably already have. There's probably occurrences of them. I worked in an area out in southwestern Montana a few years ago, and the rocks were black and very organic looking, and they were possibly about 3.4 billion years old from the early part of the Archean era. And they could possibly be inorganically produced organic compounds. But there were stromatolites associated with them, though, and that makes you kind of suspicious that they're probably biogenic in origin. But anyway, this is an interesting field of study that has not been totally investigated and has not been totally dwelt into with the very, very early record of rocks on the Earth. And I suspect that some of the black carbonaceous-looking, organic-looking marbles and black shale slates and such, that some of that could well be of something like tholins, something that is essentially an inorganically produced organic material that has left a carbon residue in these very, very ancient rocks. One of the places that you can really see that is in the Black Hills. There's these black slates that you get into the center of the Black Hills, which are somewhere around 2.8 or so billion years. They're Archean in age, and they could well be, that black material, which is essentially carbon, could well be the residue of some kind of a material like tholins or anthroxolites, which on the Earth, I guess you could use either term but the term Anthroxolite is usually reserved for carbonaceous material of very ancient age and very hard on the Earth, whereas the term tholins are organic residues. In the case of carbonaceous chondrites, are used for extraterrestrial materials. Anyway, it is a very interesting concept, very interesting topic that gets into some of the very early records of life, both on the Earth and the producing of organic compounds by inorganic means, which occurs in the outer part of the solar system and probably on other solar systems as well, which we have yet to discover. Kind of wicked stuff, actually, if you got involved with it on one of these planetary surfaces. But it's collectively known as tholins, and they're quite common in the outer solar system, as well as in carbonaceous meteorites, the carbonaceous chondrites, which look as though they have come predominantly from the outer part of the solar system.